Alrighty, welcome to Chapter 7, Unit 7, and this chapter is all going to be about parabolas. And so today we're going to learn some of the basics about a parabola. So what is a parabola? Parabolas are created by quadratic equations. And so remember, the definition of quadratic, remember that means the highest power of x is 2. So examples of quadratic, simplest is just y equals x squared. The highest power is a 2. I could also have something like this, y equals 3x squared minus 7x plus 2. Again, here there's multiple coefficients, but the highest power of x is a 2. I could also see something like this, x plus 3 quantity squared minus 5, where you'd have to write this out twice and multiply, but the highest power would end up being x squared. Or you can end up saying something like this, 4x squared minus 9. Okay, as long as the highest power of x squared, highest power of x is a square or a 2, it's a quadratic. When graphed, a parabola makes a U shape, and it can open up or down. So it's going to either look like this with arrows, because it's going to go on forever. That would be a normal U shape. That's opening up, because the arrows are pointing up. Or we could have an upside down U that opens down, because the arrows are pointing down. All right, all parabolas have a vertex. Vertex is either the highest or lowest point on the parabola. So when a parabola opens up, it will be the lowest point. There's our vertex. If it opens down, then it's the highest point. When we graph parabolas, you need to plot at least 2 points to the left of the vertex and at least 2 points to the right of the vertex. So we're not like starting at an x value of 0 and just going 2 to the left and 2 to the right of 0. We're starting at the vertex and then 2 to the left and 2 to the right. The reason being is to get that U shape, the symmetry, you have to start with the vertex and then you go 2 to the left, to the right. That's how you're going to get the U shape. And like we said here, all parabolas have a line of symmetry. So that line of symmetry would be right down the middle here, right down the middle there. All right, parabolas can have, so it says blank blank or blank x-intercepts. So it can have 0 x-intercepts. Remember, x-intercepts means where it crosses the x-axis. So if I had a parabola that looks like this, it's never crossing the x-axis. So this would be 0 x-intercepts. If I have the vertex right on the x-axis, such as that, then I would have 1 x-intercept. So I could also have 1. Or if my vertex was down here, I could have 2 x-intercepts. So I could have 0, 1, or 2 x-intercepts. In all cases, they all cross the y-axis or the y-intercept one time, no matter what. There's always one y-intercept. Here's crossing the y-intercept one time. Here, if I extend that out, it would cross the y-axis up here, and it's crossing the y-axis right there. You're only ever going to have one y-intercept. So that's the basics of parabolas so far. All right, so now we're going to look at the basic most parabola, which is we call the parent graph. So the parent graph is the simplest form of a parabola, and the parent graph for a parabola is y equals x squared. All other parabolas are originated from this original y equals x squared. So here's our equation, y equals x squared, like we said. And when we make a table, I know the vertex here is going to be at x equals 0. Okay, again, not always will it be at the middle of our table be at 0, but in this case, for the parent graph, the line of symmetry or the vertex is at 0. So I want to go to the left of that, equal points to the left and to the right. So I'm going to go 3 to the left here, because that's what my table tells me to have, and then 3 to the right. And to get my y values, I would just plug these in. So if I plug -3 in, -3 squared means -3 times -3, or positive 9. If I plug -2 in, -2 squared is -2 times -2, or 4. If I plug -1 in, -1 times -1 is positive 1. Plug 0 in, 0 squared is 0. 0 times 0 is 0. If I plug 1 in, 1 times 1 is 1. 2 times 2 is 4, and 3 times 3 is 9. So as I go to plot those points, I have -3, 9, -1, 4, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And there is my parabola that we've been talking about. So to get some key points, the vertex, remember, is that low point. So here is my vertex. It always must be written as an ordered pair. It just so happens to be at 0, 0 this time. The x-intercept means where it's crossing or touching the x-axis. So it happens to be touching the x-axis at 0, 0 as well this time. Where is it crossing the y-axis? 0, 0 as well. Our domain, remember domain is how far left and right it goes. Now, I have an arrow here, so it's going to keep going to the left forever. So that would be -infinity is less than x, which is less than infinity. And then for our range, we're talking about how low it goes. So if I took my paper, how low is it going? I stop seeing the graph right there, which is at a y value of 0. So I would set my y's up with my less than symbols. The lowest it goes is 0. I put my equal to sign. And then how far up would it end up going? Oh, it stops, but there's arrows, so it's going to go on forever. So it'll be infinity. Our line of symmetry would be right down the middle here. And the way we write lines of symmetry is we write it as anywhere on this line, our x would be 0, because it's 0, 0, 0, 1, 0, 2, 0, 3, 0, 8, 0, -4, 0, -7. The x is always 0, so we just write it as x equals 0. Our vertical lines are always x equals something. Is this a function? Yes, because it passes the vertical line test. All right, so that's what we know. That's our basics of parabolas, and we're going to be building off of these all chapter.